In our CCNP route course with dynamic routing protocols. If you want to make routing in a network, we have two options, and they are static routing and dynamic routing. Static routing allows routing tables in specific routers to be set up by the network administrator. Dynamic routing uses routing protocols that dynamically discover network destinations and how to get them. Dynamic routing allows routing tables in routers to change if a router on the route goes down or if a new network is added. In dynamic routing, routing protocols running in routers continuously exchange network status updates between each other as broadcast or multicast. With the help of routing update message sent by the routing protocols, routers can continuously update the routing table whenever a network topology change happens. And let's take a look to the enterprise network infrastructure. In an enterprise network infrastructure, we have four main parts. The first part is HQ. The second one is branch offices. The third one is data centers, and the last one is the internet edge. Normally, HQ is the place that we collect traffic which are coming from the branch offices. And in data centers, we have servers, load balancers, and some core network devices such as core routers and core switches and something like that. And internet edge is the place that we are using when we are going to the internet side. When we try to use protocols in enterprise network infrastructure, we need to take care of something. It's recommended to use a single routing protocol within the campus network, and if there is a geographically dispersed structure, it's recommended to use BGP with ISP and OSPF or EIGRP for the internal network. So how we choose which routing protocol we are going to use? The first thing we need to ask then is, what is the size of our network? If that's a real small network, for example, we can use RIP. But if it's a huge network and it's our internal size, OSPF would be better, for example. The second thing we need to ask is, do I just use Cisco? For example, some protocols or some technologies are just used with Cisco devices. EIGRP was Cisco proprietary before, but that's an industrial standard right now. But before, we could just use EIGRP with the Cisco devices. The third thing we need to take care is, what is the protocol's convergence time? Convergence time is a really important point we need to focus on, and we are going to take a look to this one. And the last thing we need to ask is, what is the scalability of the protocol as well? We are going to check all of these steps, and we are going to take a deeper look in our next slides. Let's take a look to the IGP and EGPs right now. IGPs support small, medium, and large-scale organizations, but their scalability is limited. They can quickly converge the network. The most commonly used IGPs are EIGRP and OSPF. EGPs are used to exchange routes between different autonomous systems, and BGP is the only EGP used today. The main function of the BGP is to exchange a large number of routes between different autonomous systems. And here are the routing protocol types. We have three types of routing protocols, and they are distance vector, link state, and the path vector. Distance vector protocols route according to hop count. Every router knows as much as the neighbor tells him. There's no network map on the routers, and we can give an example RIP and EIGRP for the distance vector protocols. And link state routers running with these protocols can extract the topology map of the entire network. That is, they have the knowledge of the always between 2 points. Thus, they collect all the subnets in a tree and make the best decision about which way to go with the shortest path first algorithm. They decide according to bandwidth, delay, and etc. And in path vector, route information is used to determine the best routes. Similar to distance vector, routers do not have a network map. And let's take a look to the importance of the convergence right now. Convergence is the time it takes for the routers to notice the change in the network, to share information about the change with each other, and to make the necessary calculations to find the best routes again. Today, convergence is a really big and important point. For example, if there's a problem in your network needs to converge in 1 or 2 seconds. In some protocols, it takes really long time to converge, and they are not preferred in today's networks. And the last thing we're going to talk about is the route summarization. Summarization reduces the routing load and improves the stability and scalability of shared routing information between routers. In the figure, as you can see, we have 4 routers, and we have some routes in here. 22 in here, 23 in here, 20 and 21 in here. We have 4 separate routes, as you can see. But router A can represent these 4 networks using a single network. These 4 networks, 4 separate networks, can be summarized as 10, 20, 00, and /14. And you can see that the subnet mask is used in here is /16.